said, in this video we are going to learn about IDAPython. So IDAPython is actually a Python interface to the IDAPro, and we can use it in various ways while doing reverse engineering challenges. So main aim of this video lecture is that to demonstrate the power of IDAPython and how we can automate stuffs using Python in IDAPro. So let's start. So for this demonstration I have chosen one binary. I want to show you how I debug this, how I actually crack this binary. I am going to show you how I automated this process of cracking the binary. The first place when I cracked this binary, it was manual process. Then I built some scripts which I am going to show you. uh, just one script with multiple functions I am going to show you today, and with that you can also deploy that for your future challenges or your work. So this binary is find password.exe, which just takes an password as an argument, and if it's correct gives you the valid password, otherwise greet you the wrong password message. Okay, so nothing funky stuff here. So when we open this binary in IDAPro, we are greeted with this kind of blocks. So very straightforward interpretation of this assembly, we can make that there is a string comparison happening over here, and then if it is wrong, then it is going to this way. If it is correct, then some other comparison happening, and at the end you are being greeted with the success me messages. So uh, while analyzing this binary, you can find this string. So this string is not a password, but this string is the encrypted password of this binary. An encryption algorithm to encrypt this password is written in this function, that underscore hash function. For simplicity, we'll call just a hash function here. In hash function, this password, there is an algorithm to build an encryption. So whatever password you have provided, that password is being fed to this function, and function gives a encrypted password, and that encrypted password string is then compared with this string. So if we are somehow able to build a decryption mechanism for this function, we will be able to decrypt this string, and ultimately we will get our flag in plain text. Okay, so let's go into the hash function. So in this hash function, as I told you, I have already cracked, and I have already seen this binary in manual way. So this is not our focus to look what these all functions stuff do. So while I was analyzing this binary, this block of code, I think it's just to waste the time of us, just a redundant block doing nothing. Although it's called to the random function, and we may think it's for in this binary, what actually happening, whenever you are providing a string as a password, that string is being loaded into the EAX over here. I'm sorry, the character of that string is being loaded into EAX over here, and after that, after some manipulation or something, uh, that the character is being, that ASCII value of that character is incremented by another value of EAX, which is being stored from here. So whenever, let's like say you have let's run this binary and I will show you. Before that, I will show you what is the test password I have given to this binary. Go to the debugger process option. This is our test password, ABCD, caps ABCD, and 1234. So our password is 12 digit long. That's a requirement for this uh, binary. Let's run this. Okay, so we hit a breakpoint over here, and when we step over, now we have EAX as 0, means our addition to the first character, that this ABP plus var underscore 1c is holding the first character of our string, that is it's holding a, and a is being added to the 0. That means a ASCII value of a is unchanged. So let's run again, and right now EAX is 2, you can say. Okay, so our second character is added, ASCII value of second character is being added to ECX is being held by the character which is encrypted. Now this is the ASCII value of second character plus 2. So let us look for that. Our second character was B, so let's look at ASCII value of B. Okay, ASCII value of B is 98, and let's look into the hex. It's 62, and 62 plus 2 is 64. So uh, okay, till now our assumption is correct. So now the value of EX is 5 is for the third character, then value of EX is 9, 1, then 1, then 8. So it's just a hard-coded array there. So which is coming into the picture, which is being added to the each character's ASCII value, and that's how the encryption has been made. So in order to just begin with this uh, challenge, what we need this array, we need the array of this, and once we get this array, we can calculate ASCII value of this string. Where is that? Okay, okay, we can get an ASCII value of these characters, and we can actually subtract these numbers or these value from the ASCII values of these characters accordingly, and we can get our decrypted string back. So for that, uh, when you plus when you press shift F2, we are greeted with the Python module, or with in encryption function. Okay, so what we need to do, we need to somehow uh, run our code, and once our code is running and hit once our code is running and it hit this address location, then we need to extract the value, we need to copy the value of EAX. Okay, so when in IDAPython, you can use here to get a value of your current your debugger is at. So if you look into the hex, it will be the same as this. It's 5b5. Okay, so our debugger is at this point right now. If I do F7, and step in and do the same thing here, now I'm at next location. Now I'm at next, you said, instruction. Okay, so let's build a function for that. So let's give the name to this function as a get underscore hash num, since we are going to extract number from it. And once we did that, we need to tell either run to, I'm sorry, begin EA. So we are telling IDA run from the starting position. Okay, and we need to add one more line over here. So when you do a step in using IDAPython and your debugger is also active, they are in asynchronous mode. So you need to tell wait for your debugger, and in order to continue your stepping in using IDAPython. So for that we are going to use this command, and these two commands are just basically telling IDAPython to just go and run from beginning, and it's doing nothing. But as a breakpoint, I know that at this, when my address is this address, I'm getting the EAX as my number of as number which is decremented from ASCII value of password string. So I'm going to tell if hex here is equal to, okay, I'll just copy this one. But this is not a value. I need a value. What is my breakpoint? Value of my breakpoint is 50A, so okay, I'll just make it A. Okay, make sure it's same as you're getting in this Python. If you keep it case sensitive, it won't work. I spent a lot of time with that. Then I'm telling this function to return the value of your EAX register that we are dealing with, the IDC reg value, and we are specifying the register EAX. Okay, fair enough. We got something over here. I just forget about this if condition. Okay, now run. Okay, nothing has happened. That's good. That means our IDA has taken this function. Now, in order to use it, I just need to put this function in here. Okay, so here I'm getting the value of EAX. I'll just close it, and I'll again run it. Now the value is 3, and here also value is 3, value is 6, value is 6. Okay, so it's working fine till now. So our next objective is to get this value inside one array. That's our array called as f. Okay, so I'm defining one more function over here, def get, I'll call it the flag array, like f array in this. Okay, and then for I in range, I know it's just 12 letters, 12 characters, I'm sorry. So f dot append, and in this I will append an integer value of this function which I have written out, get hash underscore num. Okay, so this is my function, and after that I will return, after that I will return f. Okay, just run it. I have another error string 14, return f. I will just print f. Okay, I think I missed something over here. Okay, let's run. Okay, it's also run. It's also ran perfectly. Now just I need to get confirmation. Get f underscore array, enter. Uh, and this is happening because I am just trying to call it 12 times, so it's actually uh, going out of condition. It's actually going out of the function hash and running entire binary. So Let's move again in Python. Okay, so we get that. So we got our array. Now what we want an sk array of our string which we found inside the function, main function. We'll just go back. Okay, okay, so this is the string. What I'm going to do, I'm going to just I'm going to get this string. I'm going to define a new function over here. Let's call this get ascii get ascii. Okay, and let s is equal to our string, and for I in s I want to go an array underscore ascii to be appended by an integer of ord of s of I 1 2 3. Correct, I think I'm correct. Okay, so let's go print uh, array underscore ascii. Okay, just run it. It ran perfectly. So let's see, get underscore ascii. Okay, so integer must be an integer, not string. Okay. Should be I. I'm just iterating all the characters of the string, and then again, my bad. Run and get. Okay, so we get another array which is which is a ascii value of this entire string. We have another array over here. We have f is 0. I think we need to initialize it. Just we will get it. Get underscore f underscore array. Perfect. We have f array. We have array underscore ascii, and okay, so we got a two array. And remember, our encryption is actually adding a character to the ASCII value of character with these arrays, the value content in this array. Okay, so 112 is being added, is being means 112 is being added to 0, or 97 is being added to 2, and 115 is being added to 5. So in order to decrypt this entire ASCII string, we have to do the reverse of addition, that's subtraction. So we are simply going to subtract each value of this array from corresponding ASCII character value. So for that, I will just define another uh, function here. Let's say the def final array. Okay, and in this I will go for I in range 0, 12. Okay, so now what I'm going to do, I'm going to append this into the our f array, which stand for and final array, and I need to append again an integer. I need to subtract this array uh, ASCII array, this value from ASCII array. So just do this array underscore ASCII of I minus f of I. There should be a completion of and 2. Okay. Okay, and I will return with this function our f array. That's it. Just go run. Let's run perfectly and go for final underscore array or array index out of range, or maybe some issues there. F. Okay, so f is not populated. I don't know why. And let's see, array underscore ascii, and both the arrays are not being populated. What could be the reason? Okay, I got it. So whenever I press run, it just nullify the progress of before. So the proper way is to write script in another editor and then import that script inside ada. But since we are doing this with while debugging, uh, we are actually losing our progress. So every time we need to just again start from beginning. Just get an ASCII. Let's check. We have f array. We have array underscore ASCII perfectly. Now time for the final underscore array. Okay, so this is our final array. Uh, while working now, this is our flag. Our actual flag. Just we need to convert that flag into characters. uh, I don't know why, but I was working with IDAPython, the CHR is not working. It's just throwing an exception to me like this. I'm sorry, just throwing an error to me. Just long object is not callable. Okay, that's enough. I can't do much more in that. But with this array, I can build another logic on separate uh, Python script, and we can get a flag from that. So for that, I have actually replicated this entire thing. And I'll do it again. Okay, so here we get a string password easy. So let's try this string in this and see whether it is our flag or not. Find, let's pass word easy, access granted. So indeed it was our flag. So we build three functions. First function is to iterate. Uh, the first function is telling IDA to run from beginning until you hit this point address, and once you have this address, just return us the value of EAX, and then we are storing that value of EAX into our function, or our array, which is f array. And after that, we are creating the ASCII value of this string, which is an encrypted string. Then we are building the decryption mechanism by subtracting the individual values from ASCII value of our encrypted string, and then finally we are getting this flag uh, by by uh, converting this ASCII value into the characters. So it was pretty simple, but yet a very powerful demonstration about IDAPython. So we can use IDAPython to our day-to-day life. This entire video intended to show you how we can use IDAPython for challenges to solve CTF and other stuff. Uh, this is my first video. I may make many grammatical mistakes. I'm not a native English speaker. Uh, I would like you to support me. I would like you to just give your comment, give your feedback, Subscribe to the channel, share if you like it, just like, and tell me what I can do to improve this video quality. That's it for today. Thank you.